Let's review a little bit about methods. Methods essentially accomplish a task. They can take in some input, do some sort of task, and potentially return some sort of output. We typically invoke a method on an object, so we most often will have a particular object and we'll ask that object to complete a task. We'll talk more about how that setup works when we get to talking about classes and objects, but for now let's just review a little bit about the general structure of methods. So in doing that, let's think a little bit about the Java flow of control. So typically Java does execute statements in order, starting with the first statement in the main method and moving forward. There are things that change that flow of control, such as conditionals, right? Cause us to take different branches so that we don't go line by line. Loops cause us to repeat lines more than one time. So there are things that can change that flow of control. Another thing that can change that flow of control is a method. So when you reach a statement that contains the invocation or calling of a method, the flow of control kind of pauses where it is and jumps to that method and starts executing that method line by line. Then when that method completes, the flow of control returns back to where the method was invoked from. So anytime you reach a method invocation, you kind of think about the original method being paused, and then you jump to that new method, execute the code in there, and when that method ends, we go back and pick up where we left off. When we invoke a method, that method ends or is completed when one of two things happens. Either we hit a return statement. So if you hit a return statement inside of a method, that's it. The method is done. Control leaves that method. Or if there is no return statement, then just once you reach the end of the method, that closing method bracket, then that would be the end of your method. So keep that in mind as we're talking about methods. Here's a little visual example. So if we have a compute method that invokes a helper method, we'll be executing all the code inside the compute method, and then as soon as we get to the line that invokes the helper method, control would pass over to that helper method. We'd execute that entire method there, and then when that method is done, control would return to where we left off and pick up and move along. If we had three methods, so here we have main, which invokes a compute method on an object, and compute still invokes helper, we start, as we always do, from our first statement in main. We start executing statements. As soon as we reach this method invocation, we jump over to the compute method, start executing methods there. When we hit helper, we jump over to helper, start executing statements, I should say, there. Notice that right now when I'm in helper, main and compute are kind of just on pause. They're just sort of waiting for the helper method to complete. When helper method completes, control returns to compute. I pick up there and keep executing until I hit the end of the compute method. Then control returns to main, and I keep executing until I hit the end of the main method, at which point my program would be finished. So that's what happens when we invoke a method. Remember, invoking or calling a method is how we actually ask the method to run, to execute its tasks, to run whatever code has been placed inside. The method declaration is when we write the method, and that just defines or declares the method. So that basically sets up what the method will do once it's invoked. But of course, it doesn't actually call it. It doesn't actually invoke the method. It just specifies what will happen once the method is called. So let's talk a little bit about that method declaration. To declare a method, we specify certain pieces of information in the method header. The method header contains the visibility of the method, so typically public or private. It can also be protected or have default visibility. A return type, the name of the method, and a list of formal parameters with the type and name of each parameter. You might also have the keyword static inside your method header. You'll either have that or not. We'll talk more about static at a later time. After the method header, you'll have the method body, which is surrounded by brackets. But when you first sit down to write your method, you want to give a little bit of thought to the method header, thinking about these four components that go into it. So for visibility, you want to think about who's going to need to access this method. For now, mostly our methods are going to be public, but eventually we can think also about making methods private. For the return type, this is the output of your method. So you need to think about what kind of information should your method send back or return once it's done, if anything. Now maybe it doesn't need to return any kind of information. Maybe it's just going to complete a task and stop. That would be a return type of void. But if it's going to return some kind of information, either a number or a string or an object, then you would use that as the return type. So you want to think about the return type as the output, the kind of the result of your method. Then you have your method name. You want to make sure to follow good naming conventions. So remember that method names use lower camel case. So they start with a lowercase letter, and if it's more than one word, each subsequent word gets a capital letter. Method names are not always, but often verbs because they usually describe a task, a job, something to accomplish. So they'll often be action words. Then you have your formal parameters. These are the inputs. So this is the information that you need to take in order to accomplish a certain task. So the return type is your output. The formal parameters are your inputs. So again, this is, you know what job this method is supposed to describe. Your formal parameters say the information you need to finish that job, to accomplish that task. And again, for those formal parameters, you list a type and a name of each parameter. So here are some examples of method declaration. So here we've got visibility, return type of void. This is the method name, and then this is the list of formal parameters. Now this particular method doesn't take any parameters. The parameter list is empty, but we still have those parentheses, which represents that empty list. So those are the 4 components. This method is private. It has a return type of int, so it's going to return an int. The name is calculate, and this takes 2 parameters, an integer x1 and an integer x2. Now because this has a return type of int, that means that somewhere inside the method we have to have a return statement that returns a value of type int. This method here, visibility is public, return type is string. The name of the method is getName. You'll see in these 2 methods here we're using that lower camel case naming convention, so starting with the lowercase and then having each subsequent word with the uppercase. This method also doesn't take any formal parameters, so we just have an empty list. And then again, we will have a return statement in here somewhere that returns, this time, data of type string. So here are some examples of method declarations. Note that when you have a method that returns a value, you have to have that return statement somewhere in your method, and you actually have to have a return statement in every possible branch. So for example, if you have an if-else inside of your method and you return something from the else only, you're not going to be able to compile that method because from the compiler's point of view, it's possible that the if branch could be executed and then there wouldn't be a return statement from the if branch. So you have to have a return statement in every possible branch of your method if your method has multiple branches inside of it. Again, void methods don't return a value, so you can think about them as just accomplishing a task and stopping. But methods that are declared as valued, meaning not void, they have to have a return statement in all branches that matches that value that you put in the method header. Now, when you're executing a method, once you hit that return statement, you are immediately done. So control leaves the method and goes back to wherever you were invoked from. So anything that happens after that would never be invoked. And in fact, most compilers now will not even let you put code after a return statement because it'll give you the error that it's unreachable code, that it can never be reached. So here's a full example of a method with the method header. So again, this is the method header. This method is public. It returns an int. The name is add. So again, that's kind of an action word. Starts with lowercase. Takes in 2 formal parameters, int n1 and int n2. We declare a local variable inside the method. So remember, a local variable is a variable that is declared inside of a method. So here we have our method brackets. Any variable that is declared, remember declaration means where you specify type and name. That's what it means to declare a method. Whenever that happens inside a method, that means that variable is local. A local variable is only visible in the method where it's declared, and it only lasts as long as that method lasts. So as soon as that method ends, that variable is gone. So here sum is a local variable. We use that to just calculate the sum of n1 and n2, and then we return it. Note that sum is, the type of sum is an int, and that matches our return type, so that's a good thing. Again, our formal parameters are the ones in the method header. These describe what kinds of input we need to accomplish a particular task. This is different from the actual values we send in when we call the method. That's the actual data we want to use. So the formal parameters just are kind of they just tell you what type of the information you're going to receive. Is it going to be an int? Is it going to be a string? And it lets you refer to that information by some whatever names you give the formal parameters. But the actual parameters are the real values you send in when you're ready to say, okay, now I actually want this method to run, and here's the data that I want to send in to get it to run. Now, one important thing to think about when methods are invoked is that there's actually a line of code you can think about happening behind the scenes every time a method is invoked. So you can think about the fact that there is this line, formal parameter equals actual parameter, for every parameter in your parameter list of the method header whenever you invoke a method. So before the method actually starts invoking, before you ever reach that first line of code, behind the scenes you have this assignment statement for each one of your formal parameters where you're taking the value of the actual parameter, the one that you passed into the method, and you are assigning it to the formal parameter. So that internally you're just going to refer to the name of the formal parameter, but first you assign the value based on the actual parameter. So here's an example of that add method, and we're going to invoke it from main. So let's take a look at main first. Here's our main method. We declare a variable that's local to main, int num1, and then we say int result equals, we invoke the add method, sending in num and the value of 2. As we're executing our code here, once we reach this method invocation, control will jump up to the add method. And here we have two formal parameters, n1 and n2. So before we ever start executing the code inside the method, it's as if we have these formal assignment statements, n1 equals num and n2 equals 2. So these are the actual parameters. These are the values we're sending in when we invoke the method. These are the formal parameters. These are how we refer to them internally to the method. And behind the scenes, we have these two assignment statements that take the value of this actual parameter and assign it to this formal parameter. And then we take the value of this actual parameter and we assign it to this formal parameter. So that's what happens behind the scenes every time you invoke a method. Now, I mentioned before that if you have a local variable, that variable will be garbage collected. It will no longer be available once the method is over. And the same is true for formal parameters. So formal parameters also only stick around as long as the method is running. Once a method is done, the formal parameters also get garbage collected. So keep in mind these differences about variables. So we have instance data variables, which we'll talk a lot about when we get to talking about classes and objects. But essentially these are variables that are declared inside of the class but outside of any method. I'm not going to talk about those right now because again, we'll talk about those more when we get to classes and objects. But then you have your local variables. These are ones that are declared within a method. They're visible only to that method. They get garbage collected when the method ends, and you want to use a local variable when really you only need a variable within that method. So a general good rule of thumb in terms of programming is keep things defined as locally as possible. So if you only need a variable inside of a method, just declare it in that method. Don't declare it inside the whole class, because if you don't need it there, that's too broad of a scope that doesn't really meet what you need. So declare variables as kind of as small or as locally as you can. Then we also have formal and actual parameters. So our formal parameters are the ones in the method header. They are also visible only within that method, so that's similar to a local variable. And again, they are also garbage collected when the method ends, also similar to a local variable. You want to use formal parameters to describe the information that's needed from somewhere outside a method in order to accomplish that task. So this is what you want to use when you're thinking about the inputs to your method. And then the actual parameters are the real values. It's the actual data that you send in when you invoke that method. So again, the formal parameters just kind of sketch out what kind of information you need. The actual parameters are saying, hey, here's the actual data. Accomplish this task with this specific value. So again, when you're thinking about writing methods, before you ever start writing the code inside the method, you really do want to put some thought into your method header, because that kind of sets up the whole structure of the method. So you want to think about the input and the output, the return type and the formal parameters. You want to give it a good name, following your naming conventions. And then you want to think a little bit about visibility. Again, right now, probably all of our methods are going to be public, but eventually you'll want to think about whether a method should be private or not as well. So we're going to just take a minute and just write a couple method headers. So we're not going to actually write these methods. We're just going to write the method headers for them. So what I'd actually like you to do is pause the video and sketch out these method headers for yourself, thinking about mostly the inputs, the formal parameters, the output, meaning the return type, and the name. And we'll probably make these all public, so you can just use that for the visibility. But pause the video, sketch that out, write the method headers, and then you can come back and play it, and I'm going to go through them. So the first is a method to print out common mathematical formulas. So what might be a method header for that? Well, the return type, we're just printing something out. we're not really sending back any information. So because we're just kind of accomplishing a task and then we're done, probably makes sense to make that. Okay, sorry about that. Assuming that we know what these formulas are going to be, we probably don't need any additional input. So it's probably okay for us to just have no parameters, so no formal parameters, just our empty parentheses. So that might be a good method header. That might not be the exact same method header you came up with. So if you got something really different, go ahead and post to the forum and we can talk about it. But you might have had something that's void with no inputs and maybe just a different name, and that's probably just fine too. Okay, a method to calculate the area of a triangle with integer base and height. So we're calculating the area of a triangle. We need to think about the return type. What might be a good name for this method? So a good name for this method might be calculate area, or perhaps you called it find area. You might have also just called it area, although again, we tend to like to be a little bit more descriptive in Java. And let's think about our input. So what kind of information do we need to take in? Well, the formula for area of a triangle is 1/2 the base times the height. So we need to take in the base and the height. And we were told in the problem statement that those are integers. So I'm going to take in two parameters, int base and int height. And what should my return type be? Well, my return type should probably be a double. Because I'm doing 1/2 times the base times the height, even though my base and height are integers, the area itself could have a decimal portion. So it shouldn't be int, it should be double to make sure I can return the full and correct area. Now, it's good to use descriptive parameter names, so I did use base and height. You might have used B and H because these are kind of common shortcuts in mathematics. That probably would be okay, but typically we do want to avoid parameter names like, naming a bunch of integers just A and B. Like that's not very descriptive. That doesn't help me inside the method know what that information represents. So you want to use parameter names that are descriptive and that help your reader of your code know what the information is. It also helps you as the programmer actually keep track of what that parameter represents. So try to use names that are parameter names that are nice and descriptive. Now you'll notice that I have a compiler error here because I have a method with a return type and I don't have any return statement. So this code isn't going to even be able to compile until somewhere in here I put a return statement. Now, just to highlight something I said earlier, let me just say, I'm just going to make an if-else statement. Okay. So here we go. So if I have an if-else somewhere in my code and I have a return statement from the else branch, if I don't have a return statement from the if branch, then I'm not going to be able to compile that code. Because according to the compiler, this branch might be executed and this branch might be skipped. And if this branch is executed, there's no return statement and I'm not allowed to do that. So I would have to have a return statement in every single branch of my code. Okay, a method to calculate the distance between 2 points. Okay, so again, I'm going to have my method be public. I need to think about the return type. We'll come back to that for a minute. I'm going to maybe call it calculate distance. Or you might call it find distance, something like that. And now what inputs do I need? Well, I want to know the distance between 2 points. So I need the 2 points. So I need to know the first x value and the first y value, and then the second x value and the second y value, for example. Now you might have made these doubles if you wanted to be able to find the distance between coordinate points that have a decimal. That would be totally fine. You also might have made them class point. There is a class in Java called point that represents just that. It represents points. And so you might have used that for your input. That would be correct too. So definitely different ways that you can structure these things, and they all can be correct answers. So what should the return type of this method be? Well, again, I think it should probably be a double because the distance between 2 points might not necessarily be an integer value. It might have a decimal portion to it. So I'm going to make that return type a double. Looks like my Eclipse is just having some trouble today. And if you did use the point class, you would need to import it to be able to use it. And of course, similar to my calculate area method, I'm going to have return statements in these methods in order to compile, because both of these methods say that they take a double as a return type. And so somewhere in there, I am going to have to return a double value. Now you might notice that I just wrote two methods with the same name. This actually is allowed. This is called this is called overloading methods, and we'll talk about that at a little bit later time. But note that you can have two methods that have the same names as long as they differ in their formal parameter list. But we'll revisit that topic another time. So finally, let's write a method to determine whether a triangle is a right triangle, meaning it satisfies the Pythagorean theorem, a squared plus b squared equals c squared. So for that method, I'll come back again to think about the return type. I might name this method is right triangle or determine right triangle or something like that. Oftentimes methods that have that are asking, this is kind of asking like a yes or no question, right? Either the triangle is a right triangle or it's not a right triangle. A lot of times those kind of methods will start with is because that sort of describes what you're doing. You're asking a question, hey, is this a right triangle? In terms of my inputs, I probably need to take in the three triangle sides. So I might call them A, B, and C. Now again, because a squared plus b squared equals c squared is how we refer to it in the mathematical formula, using the parameter names of A, B, and C is probably okay. I could have also used, side 1, side 2, or side 3, something like that. That would also be okay. Again, generally we don't try to use variable or parameter names rather like A, B, and C. These just aren't quite descriptive enough. But because those are actually the variables used in the mathematical formula, in this case it would be okay to use those. And then what should my return type be? Well, my answer to this question is either going to be a yes or a no. A good thing to use whenever you just have two possible options is a Boolean, right? True or false. It's a right triangle or it's not. So anytime you have something that's asking a yes or no question, a Boolean is a good return type for that method. And of course, again, I'm not going to be able to compile until I return some sort of value in order to compile. So that's just a little bit of practice working with method headers. Again, if you got anything that looks really different than these, or you're wondering why I use a certain parameter or a certain return type, go ahead and post to the forum and we can discuss method headers.